Section 2.4, chemical formulas. So here we're going to symbolize the composition of molecules using molecular formulas and empirical formulas, and represent the bonding arrangement of atoms within molecules using structural formulas. So the first thing to talk about is what these guys are. A molecular formula, to start with, is a representation of a molecular compound which consists of chemical symbols to indicate the types of atoms and subscripts after the symbol to indicate the number of each type of atom in the molecule. So subscripts are used only when there's more than one atom of a given type. So if you only have one atom, so like you have CH4, okay, you would write it as CH4. You wouldn't put C1H4. If it helps you, like you're on your homework and stuff, it's perfectly fine to do that. The world's not going to end. And then a structural formula shows the molecular formula, but it also shows how the atoms are connected. So here's an example. CH4, also known as methane. The molecular formula is an A. And then B is the structural formula. This is actually how it's hooked up. You have 4 hydrogens bonded to a single carbon. There's some other representations. C is called a ball and stick model, and D is a space filling model, where carbon is black and hydrogen is white. If you guys take organic chemistry, you get to learn all about this stuff. All right. Now, there are actually a lot of elements that, when in their natural elemental form, they're just individual atoms. However, some actually exist as molecules. And we have these 7 diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So in nature, these guys do not exist as just H, N, F. They are diatomics, meaning they exist actually as molecules. So H2, N2, O2, F2, Cl2, Br2, I2. So in the future, when we're doing chemical equations and stuff, and if I tell you methane reacts with oxygen gas and blah, 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 write the formula, it's not CH4 plus O. No, no, no. It is plus O2. So that is something to make sure you're aware of and that you don't get fooled by me. Elemental sulfur, most common form is S8. It also exists as S. But yeah. Here's elemental sulfur as S8. It's an interesting looking structure, isn't it? So saying things like H or 2H or H2 or 2H2, these are all very different entities. H is just a hydrogen atom. If you put a 2 in front of the H, that is not the same as H2. These are not equal. 2H just means 2 separate hydrogen atoms, whereas H2, whoa, hello, that subscript implies that they are bonded together in one molecule. Oops. Okay. So an empirical formula. Okay, so now we talk about some more formulas. And this is the simplest whole number ratio of the number of atoms in the compound. Whereas a molecular formula is the actual number of atoms of each element in a molecule of the compound. For example, benzene has the molecular formula of C6H6. Okay, but this is not the lowest whole number ratio, right? We could divide both of those by 6, and the empirical formula is CH. Acetic acid's molecular formula is C2H4O2. Its empirical formula, then, if we divided everything by 2, is CH2O. This is talking about titanium dioxide. So we're seeing less and less of this being used in things like sunscreen because it doesn't biodegrade and it's not really good for the environment. This is what benzene looks like. It's very bad for you. Don't eat it, don't drink it, don't breathe it in. It's commonly used in organic chemistry. This shouldn't here yet, but nonetheless, vinegar contains acetic acid, C2H4O2. Oh, never mind. This is fine here. So this is what this is its structural formula then versus ball and stick. So that's what gives vinegar its distinct smell is acetic acid. So if when you get to go to an actual chemistry lab, acetic acid, we have glacial acetic acid, which is basically concentrated. So vinegar is very, very dilute acetic acid. So now think of that vinegar smell and multiply it times like 100, and that's the smell of glacial acetic acid. Kind of burns your nostrils a lot, but then also makes me want a salad. All right. There's the smolder from chemist Lee Cronin. He's done a bunch of publications. He's a badass. You can see more about him and do a TED Talk he did. They link it on the OpenStax website. Okay, now isomers, we're going to just kind of introduce them here. Don't stress yourselves out. This is more of an organic chemistry thing. But it is possible for atoms to be arranged in different ways. So you might have the same number of atoms, but they're arranged differently. And these are called isomers. So same chemical formula, but different molecular structures. An example of this is acetic acid and methylformate are both C2H4O2, but have completely different structures and properties. Acetic acid is okay to eat. I mean, don't eat glacial acetic acid, but salad dressing. Methylformate could kill you. So here's their structures. They actually are somewhat similar looking, but very, very, very different properties. You switch that C and the O around and you really change things. Another example are a compound called carvones. Most of us are familiar with the smell and taste of spearmint. If you are familiar with the smell of caraway, the compound that gives caraway and spearmint, that gives caraway its odor, and same with spearmint, it's actually the same compound, but they're stereoisomers. They look almost the same when you're looking at the drawings and stuff, right? But they're mirror images of each other. You can't actually place one on top of the other and have them completely overlap and be perfect. So they are isomers. They are not the same. But it's amazing how just, taking a mirror image, how much it changes that smell. Also, fun fact, my students think it's crazy. They don't believe me, but about 10% of people cannot smell the difference between the S and R plus and minus carvone compounds, or caraway versus spearmint scent, and I am one of them. So from what my students have said, caraway smells kind of like it's more earthy and spicy, and then spearmint is minty. And from what they've described, what I smell is kind of a combination of the two, but both of them smell the same to me. I cannot tell a difference between caraway and spearmint. And yeah, if you guys know that difference in smell, you're probably like, what? If you're into essential oils, get caraway oil, get some spearmint oil, and smell the difference. And get back to me and laugh at the fact that I can't smell a difference.